All right, so our next little topic is all about predicting products. And so, with predicting products, this focuses on just one type of reaction called a double replacement reaction. And so, in these double replacement reactions, this is where we call it two cations switch places to form new compounds as products. So now let's actually look at how that kind of works in terms of just a generic ABCD equation. So if we have compound AB and compound CD, the idea is because of our way of writing compounds, it's always cation first, anion second. And so that means that A and C are essentially just going to switch spots. And so if those two are switching, that means our first product would be, well, you can say compound AD, since the A is switching with the C. And then our second compound would be compound CB. Now notice when I wrote those two, I didn't just write like AD and BC because the cations always have to be first. So keep that in mind. In this case, C was the cation, so it stays listed first as a product as well. All right, so now that we have that kind of in mind, let's talk about how to kind of go through this for an actual reaction. And so our first example here, we have sodium chloride plus potassium nitrate. Now remember, the first thing listed is a cation, so those two are going to switch spots. So if those two switch, our first product would be sodium and then nitrate, because that's what was over here. So sodium nitrate. And then our second product would be potassium chloride. And now that we have the word version, now let's go through and write it out as kind of the formulas for our reactants and products. So sodium chloride, and we'll just put our symbols and charges here. So sodium is Na plus 1, chloride is Cl minus 1. Then let's just do them all at the same time. Potassium is K plus 1. Nitrate is NO3 minus 1. Remember, that's one of our polyatomic ions. And so that does kind of help us out with all of our formulas. So the first formula that we should be writing is sodium chloride. So we have NaCl plus, then our next one, potassium nitrate, KNO3. And remember, since they were all plus and minus ones, they should just cancel each other out. And so then we draw our arrow, and then the first product we wrote was sodium nitrate. So it should be NaNO3 plus then potassium chloride, KCl. And now let's go through and check for balancing. And as we're looking and checking for balancing here, we see it's NAs are good, CLs are good, potassium's good, nitrate's good. All right, that means it's already balanced for us, which does happen sometimes. Then our next one, so example 2 here, we have magnesium sulfate and potassium hydroxide. So remember, our magnesium and potassium are going to switch spots. So that means our first product would be magnesium hydroxide. And then our second product would be potassium sulfate. All right, and so now we have both of these made. So now let's go through and write out all of the formulas for our reactants and products. So first up is kind of going through and listing all the charges. So magnesium is Mg, and the charge of it, because of where it is on the periodic table, is +2. Then sulfate is one of our polyatomic ions. If it helps, the 8 ending kind of gives that away, because if it was just a single element, most of the time it ends in "ide." Although I'm going to end up eating my words in a second. But sulfate is SO4 minus 2. Then potassium is K plus 1. And hydroxide, this is where I'm going to eat my words, because hydroxide is one of our polyatomic ions. It's OH, and it's got a -1 charge. So now that we have our charges listed, let's write out our formulas for our compounds. So first up, magnesium sulfate. Since it's +2 and -2, they cancel, so it's just MgSO4. Then next up, we have potassium hydroxide. So those are plus and -1, so just KOH. And then it goes on to produce, and then first up, we wrote magnesium hydroxide. So magnesium has a +2 charge, hydroxide is -1, so that makes it Mg, and then in parentheses, OH2. Then for our second product, we got potassium sulfate. And so for potassium sulfate, it would be K +1 and SO4 -2. So remember, we crisscross those charges down, giving us K2SO4. All right, now let's go through and start checking for balancing. So Mg, those are good. SO4, those are good. Potassium, so there's 1 on the left, but 2 on the right. And so that does mean that we need to add a 2 in front of our KOH. And then afterwards, let's check OHs. So OH is, we have 2 of them on the left, and luckily we have 2 of them on the right. So there we go, we're all balanced. But we're not always given the word versions, so let's still go through the process of doing it without the words. Now the nice thing is, remember, we just look at the first elements and we switch those. So in this case, the K and the AG are going to switch spots. And so one of the important things to know as we're doing this, though, is we do still need to do, similar to what we were doing before, we need to do this step where we were looking at charges. So potassium, if we're looking at it, and we'll write it below here, potassium, we check the periodic table, it's +1. And then since it's going to be paired up with the NO3, let's check nitrate. So NO3, and that also has a -1 charge. So it's just KNO3. Now let's look at the other product, and this one is the silver product. So AG, remember, because of the special rule with zinc and silver, AG always has the same charge. It's +1. Then let's look at NO3, or sorry, not NO3, I, because that's what it's getting paired up with. So the iodine, and because of where it's located on the periodic table, it's got a -1 charge. So it's just AgI. And so now that we have this part done, let's go through, and we can't forget to balance. So let's double check Ks, good, Is, good, Ags, check, NO3, check. All right, so it's all balanced. That's good news. And I don't know why, but I like to put smiley faces next to the balanced ones. Reminds me that I did double check to make sure. All right, and let's look at our last example here. So for our last example, we got sodium carbonate plus barium chloride. And so the sodium and the barium are going to switch spots. So that means that our first product would be sodium bonded with chlorine. And so we check some charges. So sodium is Na +1, chlorine is Cl -1. So that means it's just NaCl. And then we do the same thing. So barium, and barium, because of where it is on the periodic table, it's got a +2 charge. And then we check it with carbonate, which is CO3, which also happens to be one of our polyatomic ions. And as we look, we should see that this is -2. Okay, so that means that our formula then should just be BaCO3. All right, and so now let's go through and double check some balancing. And first up, NAs. Well, we got 2 on the left, but only 1 on the right, so we'll put a big 2 up in front. So NAs are now all set. Carbonates, the CO3s. So CO3 is, we have 1 on the left. We check on the right side. Oh, there's also a 1, so CO3 is good. Bariums, 1 barium, 1 barium, good. 2 chlorines, and then because we added this 2 here, chlorines are all balanced as well. All right, so that's it for balancing, and I'll see you guys on the next video.